Hi everyone. Today I'm excited to present 50 problems that involves finding the derivative using power rule. Okay, so let's start with the formula to find the derivative of a function using the power rule. So given this f of x, which is m times base x to the n, the power rule suggests that we multiply the exponent n to m times x raised to the n minus 1. Okay. Now, some notations to remember. Now, at times I'll start with the given function f of x. Say I have 5x plus 3, and then find the derivative. In notation, you write f prime of x, and then you say 5. Okay. Or I can just say find the derivative, which when you see the notation d by dx, that's already an instruction that you need to find the derivative of 5x plus 3. Okay, so this is already instructing you to go ahead and find the derivative. Or I can just shorten it and just write 5x plus 3 prime, meaning find the first derivative of this function 5x plus 3. Okay, so one of those three will show up in this presentation. All right, so let's go ahead and start with question number 1. So given the function f of x, I'm going to start with the easy function, and then it gets more and more and more complicated. Okay, so if we have a function that's a constant, say 5, now we know the derivative of a function is 0. Okay, by power rule, you can show that by writing the 5 with the x term. When it's just 5, it means it's 5x raised to 0 power. So demonstrating the power rule, when you multiply the 0 and 5, so 0 times 5 is just going to be 0. It doesn't matter what comes after that, right? So even if you do minus 1 here, you still have to multiply it by 0. So your f prime of x is going to be 0. So always remember, if the function is a constant function, its derivative is 0. Another explanation that will help you remember that the derivative of constant is 0 is by remembering the graph of that y equals 5. Okay, so when you graph y equals 5, so this being our x-axis, when you graph y equals 5, it's a horizontal line, okay, through 5 on your y-axis. So this is your function y equals 5, or this is your constant function f of x equals 5. And we know that the slope of horizontal line is 0. The slope of a tangent line is the derivative. So the derivative of constant is going to be 0. Okay, problem 2, given f of x equals 5x, okay? The derivative is going to be, 5. So whenever you see constant 5 or coefficient 5 times x, it's just going to be that coefficient, okay? And another way to explain is, again, using the power rule, multiply 1 and 5, it's just going to give you 5, and then x raised to 1 minus 1. So that leaves us that 5x to the 0, which is simply 5 times 1, okay? Number 3, if our f of x is equal to 5x squared, the derivative is 2 times 5, right? So 2 times 5 is 10, then x raised to 2 minus 1. Or you can just say 10x. All right, number 4, what is the derivative of x squared plus 5x minus 2? Okay, so you have this quantity prime, meaning find the derivative of this expression inside the parentheses, and that equals what? 2x plus 5, right? So you're going to use the power rule 3 times here. So this is 2 times 1 is 2x plus 5, and then constant, the derivative is what? 0, okay? It's just 2x plus 5. What about, go ahead and find the derivative of 3x to the 4th minus 6x cubed plus 4x squared plus 3x minus 5. So the derivative will be what? Okay, 12x, 4 times 3 is 12, x to the 4 minus 1 is 3. 3 times negative 6 is negative 18, x raised to 3 minus 1, okay, plus 2 times 4 is 8, x raised now to 2 minus 1, which is just 1, you don't have to show it, it's understood, plus 3x, okay, just pick up the 3, and then the constant, its derivative is 0, okay? So this is our derivative. Okay, I'm making it more and more complicated, so you can pause this and start doing the derivative, okay, if you want to. Now, number 6, if we have, okay, now you have fraction, say 2/3 x cubed plus 1/2 x squared minus 2/5 x minus 10. Okay, so 3 times 2/3, that'll be 3 times 2/3 x raised to 2, 3 minus 1, okay, plus this 2 times 1/2 x raised now to 1 minus, okay, next to x is 2/5, so its derivative is simply 2/5, and the derivative of 10 is 0, okay. Now this is reduced to just 2x squared plus x minus 2/5. Okay, did you get it? All right, nice. Let's go to number 7. 7. Okay, another fraction, x8 over 8 plus x7 over 7 minus x6 over 3 plus x5 over 10 prime. Okay, so what is the derivative? So we say 8 times x to the 7, 8 minus 1 over 8 plus 7 times x to the 6 over 7 minus 6 times x to the 5th over 3 plus 5 times x to the 4th over 10. Okay, 7x to the 6 over 7 minus 6x to the 5th over 3 plus 5x to the 4th over 10. All we need to do is simplify this to 7 plus x to the 6 minus 6 divided by 3 is 2, x to the 5th plus x to the 4th over 2. All right, let's go do number 8. How about if we have this one condensed fraction or rational expression, x cubed minus 3x squared plus 4x plus 6 all over, say, 3 prime, okay? So find the derivative. Remember, for this presentation, we're only using the power rule for finding the derivative exclusively. So there are other rules like product rule, quotient rule, but we're not going to use them yet. So we will just concentrate on using the product rule. Okay, so we have to be creative here so that we can only use power rule. Okay, this looks like a quotient, right? So we have a fraction looking. Now, the best thing to do right now is to separate those numerators sharing the same denominator 3. So we can split all of them into x cubed over 3 minus 3x squared over 3 plus 4x over 3 plus 6 over 3. Okay? And then we can use the power rule repeatedly here. So the first one is going to be 3 times x squared over 3. Now this will just cancel out. So we simply have to do 2x plus 4/3, right? Because this constant, its derivative is 0. Okay, so now it's reduced to x squared minus 2x plus 4/3. So sometimes you can break it down into small fractions, okay, sharing that same denominator. Just like number 8, number 9. Say we have this x cubed minus 3x squared plus 4x plus 6. Okay, but instead of over a constant, well, let's say it's over a variable x prime, okay? So number 8, we have denominator constant. For this number, we have denominator variable, okay? So the process will be the same. We're going to split those numerator sharing the same denominator x because we're using power rule. 4x over x plus 6 over x. Okay, and then simplify, like x cubed over x is x squared. Now x squared over x squared divided by x is x. This will cancel out, so we got the 4, and then plus 6 over x. So now apply your power rule for this simplified expression. Okay, the first one is 2x minus 3, okay, and then constant is 0. Now there's a shortcut. I presented earlier with my other video about reciprocals. Okay, there's a shortcut I made a video about. Okay, something like if you have a reciprocal, say 3 over x, when the variable plain x appears in the denominator, then the shortcut to finding the derivative is simply this. You multiply this numerator 3 to 2 over x raised to 2 plus 1. So now raised to 3. And the last thing we do is to change the sign. Again, you can do it the long way. Okay, you can do it the long way, but it would be more efficient if you memorize this process. And again, this review is gonna help you master it. Okay, so let me show you the long way to do that. Okay, so the long way is you rename the 3 over x squared first by using the property of exponent, in which you can move this x squared on top, but make sure you switch the sign. And then you can go ahead and use the power rule, see, which is negative 6, x now raised to negative 3. You take away 1, right? And then you can rename this by moving the x to the negative 3 down right here in the denominator, to then switch the sign of that exponent. So as you can see here, that's equivalent to what I got earlier using just one step. Okay. Now the reason I show you that, because you can actually use that shortcut here. You can multiply 6 and 1. Okay, that's a 6 over x raised to what? 1, but you add 1. Okay, So just like here, we have 2, but the derivative, the exponent is already 3. So 1 plus 1 is 2, and don't forget to switch the sign. Okay, okay, so that will be your derivative. Okay, to make it solid for number 10, okay, I'm going to show that again. Let's say you have 5 over x squared prime, okay? So if it's plain x, we know the coefficient is 1, okay? And thus the derivative is going to be what? Okay. So the derivative is going to be 1. Okay, now this is reciprocal. You see the x is downstairs. It's a reciprocal. So 5 times 2 is 10 over x raised to what? 2 plus 1 is 3. And then the last thing we do is switch the sign. Okay? So anytime you see this, okay, if you haven't seen my video about reciprocals and find the derivative like a shortcut. So something like if you have 1 over x, now the derivative is switch the sign and then multiply this numerator, which is constant, to the exponent of the denominator, and then over that variable x, but make sure you add 1 to that exponent, okay? So if you have something, again, like 3, let's say this is a negative 3 over x4. So the shortcut says go ahead and switch the sign to positive, and then multiply this 3 and 4, now 12 over x raised to what? 4 plus 1 is 5. Okay, very easy. Okay, number 11. Something like 2x plus, let's say you have 7 over 2x to the 4th. Okay, prime. So what is the derivative? Again, 2. Multiply this 7 and 4. Okay, that's going to be 28 over. So what's going to happen to this number 2 here? Okay, so let me show you how to deal with that 2 next to the x4. Okay, so if you want, you can rewrite this. You know that 7 on the numerator is just 7 times 1. So if you want to pull out the 1/2 times 7 over x to the 4th, okay, you can also do that, and then concentrate. Sorry, I haven't applied the derivative yet here. Okay, I'm just renaming it. Okay, so after you pull out the 1/2, then you can begin the process of the differentiation. So this is 2 plus 1/2 is like a constant multiplied by what? Excuse me. 7 times 4, which is negative 28. Okay, we switch the sign, remember, over x raised to 5. Now you can simplify by multiplying these two. Okay, so this can be reduced, 14, minus 14 over x5. Okay, let's look at number 12. Let's show you the pi. Let's say you have 4/3 pi r cubed minus 2 over r. Okay, prime. Now the variable is r. So this is like x. So the function is in terms of r. So use the power rule. We get what? 3, right? Got 3 times 4/3 pi r squared. Okay. Now this is a reciprocal right here. So we can use a shortcut. Means what is 2 times 1, which is 2, over r raised to 1 plus 1. Okay? And then switch the sign. Okay, final answer is 4 pi r squared plus 2 over r squared. Okay, number 13. Okay, 3 over x squared minus 4 over x cubed. Okay, so what is the derivative? This is a reciprocal, like constant. It's a reciprocal when your numerator is constant and your variable x is at the bottom. See, numerator is constant, and then you have your variable x in the denominator. So you can use the shortcut, which is multiply the 3 and 2 over x raised to add 1 to 2, so that's 3, and then don't forget to switch the sign. Okay, same here. 4 times 3 is 12 over x raised to what? 4. Switch the sign. One step. If you don't apply the shortcut, it's going to be very lengthy, okay? Because you're going to rewrite this as 3x to the negative 2 minus 4x to the negative 3. You know what I did? I moved the x squared on top, moved the x cubed on top. That's how you rename it first, because you can only use the power rule when the base x is a numerator, okay? Without the shortcut, see? If you apply the shortcut, then it's okay if you have the x downstairs. But if you want to strictly follow the rule of the power rule, then you have to have the x, plain x, on the numerator. So now you can do what? You can do negative 6 x to the negative 3. And this is what? Well, because negative 3 times negative 4, and then x to the negative 4. Okay? And then you can move this x to the negative 3 back in the denominator right there. Okay? So now you have negative 6 over what? X cubed plus 12 over x4. Okay? Which is the same as this one. All right, let's see number 14. Say 4 pi r squared minus 4 over r squared plus 3 over r. So this is a reciprocal. This is a reciprocal too. Okay, so this is also a reciprocal. So we can use a shortcut. So this is a very simple power rule right here. Now pi is a constant, it's a 3.14. So you can go ahead and multiply 2 and 4 pi into 8 pi r to the first power. And then the shortcut applies to this reciprocal. So 4 times 2 is what? 8 over r cubed. Good job, okay? Change the sign. Now, this is also reciprocal. So 3 times 1 is what? 3 over r squared. Change the sign. Okay, that's it. Good job. Okay, look at number 15 right here. Okay, 1 over x plus 2 over x squared minus 3 over x4 plus 5 over x5 plus 7 over x6 prime. Okay, so these are all reciprocals. Okay, these are all reciprocals. You can see every numerator is constant, okay? And then the variable x is what we have for each one, okay, in the denominator. So this should make everything solid in terms of using the shortcut for finding the derivative of reciprocals. Okay, so 1 times 1 is 1 over x. Okay, add 1 to the exponent of the denominator, now 2, and don't forget to switch the sign. And then for 2 over x squared, so go ahead and multiply. 2 times 2 is 4 over x to 3. Okay, switch the sign. And then plus 3 times 4 is 12 over x raised to 5. Okay, and then here you have 5 times 5 is 25 over x to the 6. Switch the sign. And then 7 times 6, 42 over x to the 7. Switch the sign. Okay, I'm gonna stop right here. This is just the part 1. Okay, so please join me in continuing this exercises on derivative using power rule for the second part. Okay, so we'll be doing like 50 questions, and it gets more and more complicated, okay, as we go along. So thank you for watching, and I'll see you on the second part.